Yes. So we've started. All right. So here's the deal. This is going to happen, maybe not with this class period, but with a different class, but each day, so that when kids are out, they can just tune in and they can watch that video and see what's going on. Okay. So what's that? That's what's going to make my subscriber list go through the roof. Okay. So I'll upload this one after school and then it'll be there and then those kids can do it. So, okay. So yesterday we looked at these two ideas. How do I determine a table or a mapping, whether it's a function or not? Okay. We had a definition. What's up? It's still part of 1.7. It's all started with 1.7. Okay. So it was all about looking at the domain, looking at those values on the left-hand side to determine whether or not there was that repeated x value. So today, we're looking at the other two options, equations and graphs. We're going to start with the equation, or excuse me, we're going to start with the graph and then we'll end with the equation. So based off of this, yesterday, according to this table, would you say yes, it's a function, or would you say no? Courtney? Good, right? I mean, if I look at those two values right there, I see that the same x value is producing two different y values. All right. Now, if we take this graph, that graph is these ordered pairs plotted. So clearly that means that the graph's answer is also a no. But if I took away the table and only showed you the graph, what do you need to see there that tells you the same thing that you saw in the table? Courtney? Okay, good. And you're making your hand gesture go which direction? Vertical or horizontal? It is vertical. Okay. So we're looking at those two values right there, and they're indicating to us the exact same things that they were in the table, that an x value of 2 was producing two different answers. All right. And so this has a really crazy name. It's called the vertical line test. I know, right? I know. Some people, and maybe you've heard it, they call it the pencil test. Have you ever heard of that? Okay. So same idea. If you think about drawing a vertical line and it were to cross your graph and ever hit more than 1 point at a time, that means it's not a function. So if we come back here and you thought about a vertical line passing right through there, so if I was to drag that vertical line across there, the moment it hits two of them at the same time, that's a no in terms of a function. Does that make sense to you? So if I drew my own, if it looks something like this, let's say you had a picture of the, okay, not like that. How about if it looked like this? Is that a function? So you're telling me this red line and that purple line, when they cross paths, they're going to hit two times at the same time? And that answer is no, which means then it is a function. Think like what Courtney said. She was looking vertically to see if there were 2 points that hit at the same time. That's never going to happen moving across that picture. Do you see that? But if I took this purple picture and I turned it, now, I mean, you can clearly see that it's going to hit more than once. And so that way is not a function. Yes. Yeah. This would be no, because it hits once there and once there. Originally, when it looked like that, because it would never hit more than once, then that's okay. That's a yes. That's like your domains don't have any repeats. So that only hits 1 point, right? Correct. So that is a relation. It's a function. Yeah. 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 So like, what's full sentence? Like, what's you? Okay, I don't understand what you did. Like when I turned it. Yeah. Yeah. So I was just saying, if this picture wasn't originally looking that way, but let's say it looked this way, and I just asked you the same question, like, would this be? Well, over here it's not, but as it comes this way, here it hits 1, 2, 3 times, so it's not a function. Just like saying if your domain had more than a repeated value, it's not a function. Same idea. This is just looking at it now graphically instead of in a table or a mapping. Oh, you were coloring? Okay. Well, how about this? How about those three? Are any of those functions? B is a function? B's not. Jeez. Okay. Well, so don't play the game like, well, if I put it right there on the end, it works. Because all these other places it fails, right? Okay, so this one is out. In B, are you ever going to hit blue and red more than once at a time? So it's good. What about A? You're going to hit it right there, which means, is it good or bad? It's bad, right? Think about the ordered pairs here. If you listed these ordered pairs, that's going to be 1, 2, and this one is 1, -1. So same X value, different answers. You don't want that. When you say right next to each other, are you looking horizontally? Okay, so think about, you're talking about these two, I'm assuming? Good, they have the same answer, but they started with different values, input values, right? So this is -1, -1, and that's okay. No repeat there. Yeah. On number B, that could be part of your problem right there. That one's okay. A function. Yeah. Just start, think of it this way, Sierra. If you started to put ordered pairs on all of these, well, none of them would have they would never have a repeated X because they're constantly moving either right or left, whichever way you're starting. So at no point are you going to get there and run into something like this where you've got multiple that are sharing the same result. Correct. Yeah. I don't know. So look at these four. Which one of those is a function? Which one is a function? Logan, what do you think? B. If you took your graph or your vertical line, if you ran it across A, it would hit twice. If you ran it across C, it would hit twice. If you ran it, okay. If you ran it across, okay. That's a major fail there. Where am I at? If you ran it across D, it would hit twice. But if you did it across B up there, it would never hit that one twice. So you'd be okay. If you have a horizontal line is fine. Yeah. A vertical line is not okay. Oh, it's not called the horizontal line test. It's called the vertical line test. All right. All right. How about these? These are more back to mappings. Any of those three work? So you're looking at them differently. Ian, give me one that works. Perfect. 2 is good. Because every one of these values on the left-hand side, they don't go to any other place other than 3 works. Good. Well, because nobody's playing for multiple teams, right? Joe's only playing for one team. Kathy's only playing for one team. Number 1 is in or out? Out. It's a true statement. Right, because they're going 2 places. It's not wrong, but it's not a function by definition. Sure. How about these 3? Do any of those work or any of those functions? 4 works, okay. Okay, good. 5 does work. That middle line is not part of the picture. It's the y-axis if you're looking at that. So the only part in 5 is actually the V shape there. So it's a function. Sorry. Super apologies. How about 6? Good or bad? Bad. All right, what about these 3? 7 is good? What's wrong with 8? It's already a vertical line, right? So if you think about trying to place this red line on top of that line, they're all going to hit. So they're all out there. Okay, so what if we take it all the way and it's just back to basically a relation? Is the relation a function in number 10? What are you focusing on? The left number, yeah, or the domain. So 7, 4, 3, and 2, none of those repeat. So you know you're good there. And how about 11? And 11 is good too, right? 0.9, 1.4, and 3.2. Don't look at all the 1.4s because you don't necessarily care about their range value. You care about their domain or their y value. Okay, so if we come back here for 1 second, that now means we've taken care of tables, mappings, and graphs. In your personal opinion, what's the easiest one to recognize? How many of you say table? Okay, how many of you say mapping? How many of you say graph? Okay, listen, you're not wrong into any one that you say, and really leaving your hand up multiple times because they really all are telling you the same thing. All right, it's whether or not you visually see it through a graph, or whether some of you, I think, probably like the mapping because you see like the split coming off of there, or the table. You know they're all lined up. You just got to run your eyes down that table and see if anything matches. So all of them are telling me the same thing, just a little bit different. But the last one is this equation. How do I know in an equation? And so we're going to need to put this in our notes over here where it says function notation. So for those of us at home, it's going to look a little bit different, but it's going to come off of here. You don't need to write this down. That over there. You guys in class, we're going to fill this in over here on the side. Okay, but what function notation is, it's a way to represent an equation through function form. And so what's going on here is basically how it's going to be written. And how it's going to be written is with this statement here, this f parentheses x. For us, we're going to write that over here, f parentheses x. But when we read it or when we say it out loud, we're going to pronounce it as f of x. And essentially what we're saying is a function of x. Okay. Now down below there where it says the dependent variable is a function of the independent variable, the fact that it's in 4 different colors is because we're going to put in 4 different things. So somewhere in your notes, can you write that sentence, but make sure that it's all on the same line, because ultimately we're going to fill something in underneath each one of those. And if you have them on 2 lines, I guess that's going to make our fill-in look a little weird. Mathematically speaking, the dependent variable is what? What is our dependent variable? It is, well, it could be the range. Correct. And as far as we're concerned right now, would that be X or would it be Y? It is Y. Okay. So underneath where it says the dependent variable, we're going to put in the letter Y. So it's kind of this piece here. We get a Y. Okay. Mathematically, the word is means, starts with an E if you're not sure. It's what? Equals. So Y is, or Y equals, we are going to denote the word or the phrase a function of with the letter, I'll just take a wild guess, not X, F. So this function is going to get represented by the letter F. And the independent variable in this scenario is, it is X. So essentially what we have here is that Y is really the same thing as F of X. So instead of having an equation that maybe says Y equals, what you may start to see are equations that say F of X equals. And that f of x is simply standing for a function of x. So that means it carries all the properties of a function. Okay. So we would know what it would look like table-wise or mapping-wise or graph-wise simply by the heading f of x at the beginning. So that may look something like this. Okay. So there's a function. F of x is equal to 3x minus 4. It says find f of 4. Any clue what that means? What's being asked of you in that scenario? Find f of 4. What is 4 in place of? Which means then we're going to substitute 4 in anywhere we see an x. All right. So what we really have here is we have a statement that looks like this. F of 4 is equal to not 3x minus 4, but now 3 times 4 minus 4. So where there was an x, I replaced it with a 4. So what is f of 4 equal to? Well, f of 4 is equal to 8, because if I did 3 times 4, I would get 12, and 12 minus 4 is equal to 8. So you kind of have almost what looks like an ordered pair. When x is 4, the y value is 8. Okay. If we took this and we said find f of negative 3. So now I'm not plugging in a 4. Now I'm plugging in a negative 3. So take a second, plug in that negative 3 and tell me what is the answer now in this function. F of negative 3 is equal to, and you should be thinking like this. Ruby, what do you got? There you go. So f of negative 3 would be negative 9 minus 4. That'd be negative 13. Okay. And so as I create these inputs and outputs through the independent and the dependent, right, I get x values and I get corresponding y values that go with it. So with that being said, try that one and tell me what you get. So find f of 3 plus one more. So for a second, forget the plus 1. Find what f of 3 is. When you get your answer, then add 1. You already have it? All right, hold on one sec. Now this is a new function, right? This is not the same function that was there before. So we're going to go 2 times 3 minus 4, because that's what the new function says. So what is f of 3? Ian, on its own, what's f of 3? Yeah, like before the plus 1 part. 2, right? If you did 2 times 3 here, you would get 6, and 6 minus 4 would leave you with an answer of 2. So that's the answer to f of 3. But the problem asks for f of 3 plus 1, so you would say your final answer is 3. Right? I had an answer of 2, but I had to add one more to it. Okay. Now, if I have more than one function at a time, it would get confusing to write f of x more than once because, well, are you talking about the first one or are you talking about the second one? Just like if I had more than one variable, I don't use the same variable. I may have x's and y's at the same time. You with me there? So if I have more than one function, I don't write f of x again. You want to take a wild guess as to what letter I might use instead of f? Don't overthink this. The most commonly used variable is x, and the next most commonly used variable is y. Do you know why? Because it comes alphabetically after it. So if f of x represents a function, what do you suppose the next letter would be? I'll give you a second to go ahead and count your alphabet in your head for a second to land on G. Okay, so if I had another function, I may call it g of x. Let's say this time I had 6x plus 3, and I wanted you to find 4 times g of 5. Which part for a moment are you not going to even worry about? Ian? The 4. Forget it. Figure out what g of 5 is. When you get that answer, what are you going to do with the 4? You're going to multiply it because it's sandwiched right next to it. So it says to multiply. I just need to figure out what it is first. So take a second, figure out what g of 5 is. All right, plug in the 5 wherever I see an x. Six times 5 plus 3 more is a grand total of 33. So g of 5 is 33, but I'm looking for 4 times g of 5. So I need 4 times 3. Sorry, 4 times 33. And that's an answer of 132. You wouldn't have got that? Oh, don't you remember when we did the distributive property? You could have split 33 into 30 and 3. 120 plus 12. All right. Last one. Okay. So now I've switched it from H or from G to H. We had a third function. I know. But here it says that H of t represents 180 minus 16t squared, and that represents the height of a ball thrown from a cliff that's 180 feet above the ground. Don't act like you guys have never been on something high and thrown something off of it. By mistake, or just, oh, don't act like you never chucked something off the top of a building or, never? All right, you're a good kid. All right. So in this particular case, I no longer have a variable of x. I've switched it out to a t. Why do you think it's changed into a t? Nah. T stands for something here. Think about it. You're Courtney? It is. But in this particular case, what do you actually think the T stands for? Come on, you're talking about a ball in its relation to its height versus time. So when we say h of 2, what I'm really saying to you is, what's the ball's height after 2 seconds? That's what that is really asking you in very small terms. What's the ball's height after 2 seconds? I'm not going to find it any differently. I'm going to plug a 2 in there and solve, but that's what it's asking me. Sorry. When you sub in the 2, what's getting squared? Is it just the 2? Or is it the 2 and the 16? You think it's both? Okay. Well, come back up here. The 2 right now, is it attached to the t or is it attached to both? If it was attached to both, what would need to be there that's not currently there? Parentheses. So the only thing that it's currently attached to is the 2 or the t. So when you square down here, the only thing that should be getting squared is the 2. So absolutely. So that would leave you with 180 minus 16 times 4, which is 64, which means after 2 seconds, the height of the ball should be 116 feet. Okay? Now, when you guys come to class tomorrow, I'm going to give you a review that mirrors what you'll see on your test on Friday. If you can do the things on your review, you're golden for your test on Friday. If you look at it and say, I can't answer this one, or that one, and you don't do anything about it, well, guess what? When you come in here, you're going to find problems very similar to that you struggle with as well. So that's what tomorrow is all about in terms of us being able to